This is a key to the worksheet on topics 11 through 14. And the title of this worksheet is called Various Rational Expressions Worksheet, and this is number one. All right, now in part A, these were multiple choice items. So let's look at number one. So number one says, find any values for which this expression is undefined. So this rational expression is undefined. Well, remember, a rational expression is undefined when the denominator is zero, not the numerator. So the numerator can be zero, but the denominator cannot be zero. So what we have to do is find out where's this polynomial that's in the denominator, where's that equal to zero. So in number one, the way you should have done this, number one should have been this. So you would have said, all right, so this is number one. So you would take the denominator, that polynomial that's in the denominator, so x cubed minus 7x squared plus 12x, and you have to determine for what values of the variable is this polynomial equal to 0. And so when solving this polynomial, notice the first thing you need to do is factor out an x. So factor out the GCF. So the GCF here is x. So this becomes x times x squared minus 7x plus 12 equal 0. And then factoring this trinomial that you see that's inside the parentheses, we get x times, and then let's see, in terms of two binomials, this is x times x is x squared. 12, we're going to go ahead and use 4 and 3 because the last sign's positive, so these signs have to be negative, and that's the only way you can get a negative 7x is to have a negative 4 here and a negative 3 here. Okay, now once you factor this polynomial, then remember you have to use a zero factor property because you have three factors. Notice there are three. One, the variable x, the expression x minus 4, and the expression x minus 3. So there are three expressions whose product is 0. So one of these expressions has to be 0. One of these factors has to be 0. So we're going to set each of these factors equal to 0. And then it's just a matter of you solving for the variable x. Well, notice that over here, the variable x is already by itself. So one of my solutions to this polynomial equation is 0. The other one would be x equal 4, and the other one would be x equal 3. Now, let me remind you what we just found. So we found three values for the variable. So when x is 0, when x is 4, and when x is 3, this polynomial is 0, which means that this rational expression, the denominator is 0, which makes it undefined. So the values of the variable that makes this rational expression undefined are 0, 4, and 3. And so that would be, I guess, 0, 4, and 3. So that would be choice A. All right, so that's the answer for number one. So number one, the answer is A. All right, number two, you're asked this in number two. It says find the numerical value. So find the numerical value of this rational expression when x is negative 2. So basically, where we see the variable x, you're going to substitute negative 2. All right, so I'm going to go ahead and rewrite the problem. So here's number two. So number two, our rational expression is x minus 2 divided by 2x squared minus 7x minus 15. And then I want to find out what is the value of this rational expression when x equal negative 2. Now you have to be careful because the value of x here is negative 2. So I'm going to use parentheses in some of these substitutions. So the numerator, I get negative 2 minus 2. So that becomes negative 2 minus 2. The denominator, now you got to be careful. Make sure you use parentheses where appropriate so you don't get the wrong value or get the wrong answer. So I get 2 times in parentheses, you got to put that in parentheses because x is negative here, and you're squaring that, minus 7 times negative 2, notice I put that in parentheses, and then minus 15. I'm going to just make sure you extend this division symbol. Now notice I did not put negative 2 in parentheses here because it's easier to see that negative 2 minus negative 2 is a negative 4. All right, now over here, so in the numerator obviously is negative 4. Now in the denominator, you got to be careful. You got to use the order of operations. So I've got to use exponents first. So negative 2 squared is 4. Okay, 4 times 2 is 8. So I get 8 here. Negative 2 squared is 4. 4 times 2 is 8. A negative 7 times a negative 2 is a positive 14. And then minus 15. All right, and so I get now, you remember you should add and subtract from left to right, but there are times when you can recognize, well, I could add 14 and negative 15 first without having an issue, and that's true. 14 and a negative 15 is negative 1, and then negative 1 plus 8 is a positive 7, so I get negative 4 sevenths. So you could say 8 plus 14, which is 22, and then 22 minus 15 is 7. All right, and so the answer for 2 is 4 sevenths. So that would be negative 4 sevenths. So that would be choice C. So choice C is the answer for number 2. So number 2, the answer is C. All right, now number 3. Number 3, we have this. So you want to find a rational expression that's equivalent to this. Now, first of all, notice that I cannot factor the numerator or the denominator. So the fact that you have choices here kind of helps you a little to kind of determine, well, how do I determine which of these rational expressions is equivalent to this when I cannot factor, when the numerator and the denominator cannot be factored. All right, well, here's the idea. So in number 3, the idea is this. You have to remember that in number 3, so let me go just do and recall here. So recall that if I have negative 1 divided by 2, let's say, and notice that the 1/2 is negative. So I have that negative in front of this fraction 1/2. That's equivalent to taking the opposite of the numerator. So the opposite of a positive 1 is a negative 1 divided by 2, or taking the opposite of the denominator instead. So that's the same thing as saying 1 divided by negative 2. So notice negative 1 divided by 2 is the same thing as the fraction negative 1/2, and then 1 divided by negative 2 is the same thing as negative 1/2. But be careful. Some students seem to think that this means this, and some would put does not equal, so that does not mean negative 1 divided by negative 2. So you don't take the opposite of the numerator and the denominator, because obviously you can see a negative divided by negative is a positive, right? And so those two are not equal. So don't make that mistake. So whenever you have a negative in front of a fraction, you can rewrite this as by changing by taking the opposite of the numerator or taking the opposite of the denominator. All right, so using that idea, let's look at number 3. So number 3, we have this expression. We have negative 4 minus 3x divided by 5x plus 6. So based on what we just talked about, so you see that I have this fraction, this rational expression, and there's a negative in front. So that means I can rewrite this by taking the opposite of the numerator. So in other words, that's going to equal, so I can kind of distribute the negative in the numerator. So it becomes a negative 4, and the opposite of a negative 3x is a positive 3x divided by the denominator. Remember, you only take the opposite of the numerator, or you take the opposite of the denominator, but not both. And so since I took the opposite of the numerator, then the denominator stays the same. Okay? Or I could have done this instead. I could have kept the numerator alone, so 4 minus 3x, and then taking the opposite of the denominator. So this expression is equivalent to taking the opposite of the denominator, so negative 5x minus 6. Okay? And so there are multiple ways of writing this also. So notice, remember addition is commutative, right? So if I want to, I could say, leave the denominator as 5x plus 6, but I could say 3x minus 4. So I just want you to notice that that all of these are equivalent. And you could have said, well, could I write it as 6 plus 5x? Sure you can. Addition is commutative. So you could have said 3x minus 4 divided by 6 plus 5x as well. All right. And over here, same thing. I just want you to notice that this right here means the same thing as negative 3x plus 4 divided by, if you want, you can rewrite this as negative 6 minus 5x. So those all mean the same thing. All right, but the main point's this. Whenever you have a negative in front of a rational expression, you can rewrite this by distributing the negative in the numerator or distributing the negative in the denominator. And then there are multiple ways of writing what you have. So based on all these possible answers here, all right, let's see what choice is available. So let's look at part A. So part A, notice what they did. All they did in part A was taking the opposite of 4. But remember, you got to take the opposite of the numerator. All terms, it's in the numerator. So obviously it's not that because of that negative 3x. In part B, what they did was notice they took the opposite of the numerator and the denominator. See that? So 4 became negative 4, negative 3x became positive 3x, 5x became negative 5x, 6 became negative 6. So that cannot be true because we just saw that this right here does not mean take the opposite of the numerator and the denominator. It means take the opposite of either the numerator or the denominator. And then I just want you to notice that B and C are the same thing, aren't they? So negative 4 plus 3x is the same as 3x minus 4. So I just want you to notice those are the same expression. They're just written in a different way. Okay? And so the answer is D. So notice what the choice that they chose was to take the opposite of the numerator. So the opposite of a 4 is negative 4. The opposite of a negative 3x is a positive 3x. All right? So the answer for 3 is D. So the answer is D. Okay, so let's look at number 4. So number 4, you want to simplify this rational expression. And so let me go ahead and rewrite number 4. So number 4, we have 36c to the 5th power, d to the 4th, divided by 96c d to the 8th power. All right, and so you may need to use your calculator with this to determine what factors I can reduce 36 and 96. Obviously, they're both even, so you could divide by 2, but there could be something larger than a factor of 2 that you can use. So let's try, for example, let's try 6 and see if that works. So obviously, we all know that 36 divided by 6 is 6, but let's see if 96 is divisible by 6, and it is. All right, so I'm going to go ahead and think of it this way. So I'm going to write this as 36 divided by 96 times c to the 5th divided by c times d to the 4th divided by d to the 8th. All right, now reducing this, these are both divisible by 6, so that's going to be 36 divided by 6 is 6, and then 96 divided by 6 is 16. Now obviously that 6 was not the largest, right, because noses are still even. And so I can reduce that by 2 now. So 6 divided by 2 is 3, and then 16 divided by 2 is 8. So far I have this. I have 3/8. Okay, times. Now let's think about what this is. So notice I have 5 factors of c in the numerator, and I have 1 factor of c in the denominator. So I can reduce all of this with one of these. I'm left with 4 of them. So this becomes c to the 4th divided by 1. So c to the 5th divided by c means the same thing as c to the 4th divided by 1. Now over here, I have 4 factors of d in the numerator only and 8 in the denominator. So all of these will divide into 4 of these. So I'm left with 4. And so this is 1 divided by d to the 4th. And so now writing your answer as one fraction, you have to write it as one fraction. You have 3 fractions that I've written here. As one fraction, I get 3 times c to the 4th times 1 is 3 c to the 4th. And then 8 times 1 times d to the 4th is 8d to the 4th. All right. And so for number 4, it looks like the answer would be D. So the answer is D. So the answer you'd say will be D. All right. Okay, so that's number 4. All right, let's look at number 5. So in number 5, we have this for number 5. All right, so we have, you want to write the following expression in lowest terms, so you simplify. All right, and so let's see what we have. So I'm going to go ahead and rewrite this over. So number 5, we have 1 minus w divided by w squared minus 1. Okay, so if I factor the denominator, I get, in the numerator, I get 1 minus w. The denominator is the difference of two squares. I get w minus 1 times w plus 1. Now remember, you got to think of opposites sometimes. All right, so opposites. And so if you think about this, the opposite of 1 minus w is, and remember, the opposite, you just change the sign. So is negative 1 plus w, right? Or w minus 1. So those two are the same thing. So notice, here's a w minus 1. So these two are opposites. And so you got to remember, when you divide opposites, remember you divide opposites. So for example, negative 4 divided by 4, remember that's a negative 1, right? So when you reduce, 4 divided by 4 is 1, negative 4 divided by 4 is a negative 1. So when you reduce opposites, we tend to make the denominator factor 1 and the numerator factor negative 1. All right, so since these two are opposites, that's going to equal negative 1. Those are opposites. So negative 1 divided by 1 is negative 1. So this is 1, this is negative 1. And it kind of makes sense. I want you to think about this, why also that's true. So if I have 1 minus w divided by w minus 1, and I factor out a negative 1 from the numerator, if I factor out a negative 1 from the numerator, I get negative 1 times a negative 1 is a positive 1, and a negative 1 times a positive w is a negative w. And the denominator, I get w minus 1. Well, notice these two are the same. Negative 1 plus w is the same as w minus 1. So those divide out, and you're just left with negative 1 times 1 is negative 1, and then divided by 1, which is what you see here. All right, so there are multiple ways of thinking about this. But the fact here is that you did have to recognize that those were opposites. And so when you reduce, you got to make one a factor 1 and the other one a negative factor, a negative 1 factor. And so therefore the answer is going to be negative 1 divided by w plus 1. So negative 1 divided by w plus 1. Now, remember what we just talked about in our previous problem right here. So see how we have that negative in front? So if you want to, you can rewrite this as writing this as negative and then 1 divided by w plus 1, where you have the negative in front of that fraction. So this right here means the same thing as this. And so that would be choice C. See where the negative's out in front? So that's choice C. And so the answer for number 5 is C. Okay, number 6. So in number 6 is actually where is part 2. And in part 2, you did have to show all your required work. Now it says show required work. So you know what I mean by that. You have to make sure, first of all, you factor. And then secondly, you have to show me what's being reduced. So that's this idea here. That's this idea. You got to tell me how you're reducing. Now in the first 5, you didn't have to show any work. But in number 6 and 7, those you did have to show work. So let's look at number 6. So number 6, we have x squared plus 7x plus 10 divided by x squared plus 2x minus 15 times 4x plus 12 divided by 3x plus 15. Okay, so the first thing you have to do, the first thing you had to show me was that you factored first. So in that numerator, the first numerator, I can factor that as x plus 5 times x plus 2. The denominator, I can factor that as x plus 5 times x minus 3. The numerator here, I can factor out a 4, so get 4 times x plus 3. And then the denominator, I can factor out a 3, so get 3 times x plus 5. Okay? So it looks like that's about all I can factor. Now, once you factor, let's go ahead and reduce. So I see a factor of x plus 5. I see one here. In fact, there are two of them aren't there. So it doesn't matter which one I reduce. So I'm just going to reduce these two. Make sure you put factors 1 because that's what it is. X plus 1 divided by x plus 1 is 1. The next factor C is x plus 2. There's no factor of x plus 2 in the denominator. The next factor is x plus 3. There's no factor of x plus 3 in the denominator. So that's about all I can factor, right? And so therefore, all right, let me just make sure I did all this correct. All right, so that's about all I can factor. So I'm going to go ahead now and rewrite this as 4 times, so that's 1 here, so 1 times x plus 2 times 4 times x plus 3. So see, I have 1, 2, 3, 4 factors. 1, 2, 3, 4. We always tend to put the monomial first. And I'm going to go ahead and put x plus 2 next. So 4 times x plus 2 times x plus 3 divided by, and then this would be 1 times these 3 factors, and let's put the monomial first. So 3 times x minus 3 times x plus 5. And leave it in factored form, because if you do go ahead and multiply this out, the numerator and the denominator, and you have an error, so you say equal and you have an error, you're going to lose points because mathematically what you wrote is not correct. So leave it in factored form. All right, so that was number 6. So the only thing I could reduce is this one, the x plus 5s. All right, so number 7, so let's go to 7. So in number 7, I have I have a squared minus b squared divided by, so a squared minus b squared divided by 2a minus 2b, and that's being divided by 8 divided by a plus b. All right, now the first thing you have to do when you're dividing rational expressions is change this to multiplication problem. So we have a squared minus b squared divided by 2a minus 2b times the reciprocal of the rational expression following the division symbol. So the reciprocal of 8 divided by a plus b is a plus b divided by 8. All right, now let's go ahead and factor. So the numerator here, that's the difference of 2 squares, so I get a minus b, a plus b. The denominator, I can factor out a 2, so that's 2 times a minus b times, and then a plus b divided by 8. And again, it looks like the only thing I can factor out, I can reduce rather, is the a minus b's. All right, make sure you show how they're reduced. You need to show it so you don't lose any points. And so therefore, the answer then would be, there are a couple ways you can write this. You can say a plus b times a plus b, just like this, divided by, now you got to say 2 times 8 is 16. Okay, you are expected to know that. 2 times 8 is 16, so you must say 16. Or if you want to, you can write this as a binomial squared. So you can write this as a plus b squared divided by 16. All right, so that was number 7. Okay, now let's look at number 8. So number 8, it says, now this is part 3, so we're doing multiple choice again. So in both number 8 and 9, it looks like you want to find the least common denominator for each list of rational expressions. All right, so let me go ahead and rewrite number 8 and 9 over. But remember, when you're finding the least common denominator, you got to look at all the factors that are in the denominators. All right, so you must consider your factors in the denominators. So if we look at number 8, so number 8, we have 5 divided by 6ab cubed, comma, negative 7 divided by 2a squared, comma, and then 9 divided by 4b squared. So notice that these are all monomial factors. All right, so when finding the least common denominator of monomial factors, let's first of all look at the coefficients. So we have 6, 2, and 4. So the smallest number that 6, 2, and 4 going to would be, in this case, what, 12? All right, 12. All right. Now, your next factor that you see is A. So I must have an A. It doesn't matter. You see, A is not here. It does not matter. Your least common denominator must include the factors that you see in your denominators. So I see a factor of A, but I need to make sure I use the least common denominator. So I have A to the first, A to the second, and then there's no factors of A here. So you must use the one with the largest number for the exponent. So you must use A squared. All right, it's because A goes in A squared and A squared goes in A squared. And then the next factor I see is a B, so I got to use it. And the question is, how many do I need? You got to use the one with the largest exponent. So there are 3 factors of B here. There aren't any here, and there are 2 here. So I must use the one with the largest number of factors. So I've got to use B cubed. So there's your LCD. So in the next lesson, when you add or subtract these rational expressions, you're going to be using the least common denominator, which is this. All right, so number 8, the answer is this. So that would be, it looks like, I guess B. Let me make sure that's correct. So 12a squared b cubed, 12a squared b cubed. So the answer is B. So number 8, the answer is B. All right. Now number 9, here's what we have. So same idea, you want to find the least common denominator. So you have x minus 3 divided by 2x squared minus 9x plus 4, comma, and then 2x plus 7 divided by 2x squared plus 9x minus 5. Okay, so remember what you got to find the least common denominator. So you must look at factors. So you got to look at your factors in the denominator. So in number 8, those were monomial factors. Number 9, these are not factored. These are not in factored form. So also keep in mind, you're only looking at the denominator. You're trying to find the least common denominator. Don't worry about the numerator. It's the denominator you gotta make sure you factor. So you gotta make sure you factor the denominators. So 2x squared minus 9x plus 4, let's go ahead and factor that. So let's see, that'll be 2xx, 4 and 1, and then both negative. Now over here, let's see what we get. We get 2x, x, that's a 2x, and then 5, 1, this has to be positive, this has to be negative. And then and we get this 9x as the middle term. So your least common denominator must include every factor you see. So I have 2x minus 1 occurring as a factor here. No, there's only one factor. And then 2x minus 1 occurring as a factor here, so I can only use one of them. If you put 2, don't make the mistake and put 2. It's no longer the least. You must write the least common denominator, not just any common denominator. So don't say, well, I see 2 factors of 2x minus 1 in my denominators, so why can't I use 2 of them? Because it's no longer a least common denominator. It becomes a common denominator. All right, so you need to be careful. And then if you were to actually use a common and not the least, if you were adding these, you would have a difficult time coming up with the final answer. Okay, the next factor C is x minus 4. There's a factor x minus 4 here. There aren't any here, and there's only 1 here, so I'm going to put 1. The next factor I see is an x plus 5. There aren't any here. There's only 1 here, so I'm going to put 1. So your least common denominator is comprised of these 3 factors, and you must write them as a product. Don't put commas here. You're going to be upset. You're trying to find the least common denominator. So the least common denominator is a product of all the factors that are in the denominators. All right, so note the same thing here. I wrote this as a product. All right, so it's number 9. Okay, let's look at number 10. So number 10, let's see what number 10 says. Okay, so number 10, you want to add or subtract these rational expressions. Notice in number 10, the denominators are the same. Number 11, the denominators are the same. And number 12, the denominators are the same. So these are the easy kinds to add or subtract. So let's look at number 10. So number 10, I have this. Now, also keep in mind that, it does say no work needed, but for some of this, some work is needed because at some point you may need a factor and then knows this is subtraction here. So writing things down does help with organizing your thoughts. Okay, so number 10, we have 3r plus 1 divided by r minus 4, and I'm subtracting this rational expression, r plus 9 divided by r minus 4. Now, since the denominators are the same, I can write this as one rational expression, and you just keep that denominator. So the numerator here will become 3r plus 1. Subtract this numerator. So you're subtracting all of this. So put that in parentheses. And so now this becomes getting rid of the parentheses by using distributive property. So you distribute this negative symbol, this negative 1. I get 3r plus 1 minus r minus 9. Okay? Divided by r minus 4. Combining like terms, I get 3r minus r is 2r. 1 and a negative 9 is a negative 8 divided by r minus 4. All right. And then factoring out a 2, I get 2 times r minus 4 divided by r minus 4. And notice these r minus 4s, these factors divide out. So you get an answer of 2. So you don't stop here and think that's the answer. First of all, it's not a choice, right? It's not a choice, but it could have been. It could have been a choice because it does say write each answer in lowest terms. So you need to know to write your answer in lowest terms. But the correct answer is 2. All right, so the answer is 2 there. All right, but notice you did have to do some work, even though I did say no work needed. You did have to do some work there. All right, number 11, let's look at number 11. We have a squared divided by a plus 2 plus 2a plus 4 divided by a plus 2. So again, I'm adding two rational expressions whose denominators are the same. So I can write this as one rational expression now, since the denominators are equal to each other. So I'm writing one rational expression. So this becomes a squared plus, now whenever you're adding, that's the easy kind. So this becomes a squared plus 2a plus 4. So notice I didn't put any parentheses here like I did here. I put parentheses here because I was subtracting all of this. So if you don't put parentheses, you're going to make a mistake and probably would have said minus r plus 9 instead. So instead of plus 9, it needs to be minus 9. Okay, now just like when you get to that point, don't say that's the answer. You gotta factor and then see if you can reduce. So I can factor the numerator, so that becomes a plus 2 times a plus 2. Okay. And the denominator is a plus 2, and notice I can reduce. Doesn't matter which one I reduce, does not matter. I could have reduced these or these, does not matter. And so the answer is just a plus 2 divided by 1, which is a plus 2. All right, so the answer is a plus 2. So that would be, in number 11, that would be C. So the answer for number 11 is C. So number 10, the answer is D. And for number 11, the answer is C. All right. Okay, let's look at 12. So number 12, we have this in number 12. We have x squared divided by x plus 1 plus 6x plus 5 divided by x plus 1. All right, so notice again I'm adding, so that's the easy kind, and also the denominators are the same. That's the easy kind. So I can write this as one rational expression, and the numerator of this rational expression here will be x squared plus 6x plus 5. But remember, don't stop there. You gotta write your answer in lowest terms. So you gotta factor the numerator if you can. In this case, I can factor the numerator. And so the numerator I can factor as x plus 5 times x plus 1. The denominator is x plus 1. And now notice I can reduce. So you go ahead and reduce. And so the answer is just x plus 5. X plus 5 times 1 is x plus 5. X plus 5 divided by 1 is x plus 5. So that would be choice C also. All right, so number 12, you have the answer is C. All right. Okay, 13. Let's look at 13. So 13 is the same thing. You're subtracting and adding rational expressions. Notice that the denominators are the same. So let's look at that. So let me go ahead and rewrite this over. So I get 6x minus 6 divided by 3x squared minus 14x plus 15. Subtract. And then 4 divided by 3x squared minus 14x plus 15. All right, now I did say no work necessary, but you do see you have to do some work. So there's some work that needs to be done. So notice though that the denominators are the same. So I'm going to write this as one rational expression with that denominator. So my denominator is 3x squared minus 14x plus 15. The numerator, I have 6x minus 6, and then subtract 4. Now notice I'm not putting that in parentheses like I did this one. So remember number 10, I put that in parentheses because I'm subtracting. And I put that in parentheses because it was more than one term. So here I had two terms. Here that's just one term. Putting parentheses around here is not necessary. So let's go ahead and combine like terms in the numerator. So when I combine like terms in the numerator, I get 6x minus 10, right? Divided by, and then let me go ahead and rewrite the denominator. And then I want to remind you. So just like we did in number 10 and 11, in number 10 and 11, you need, once you get to that point, you need to factor. Once you get to this point, you need to factor if possible and then reduce. So I'm at that point now. So in the numerator, it looks like I can factor out a 2, right? And so I get 2 times 3x minus 5. The denominator, let's go ahead and factor this trinomial. So I'm going to go and do the two binomials. So 3x, I need a 15, and that's so that's an easy kind because that's a positive 15 here. So these signs have to be the same, and they have to both be negative. And let's just make sure that works. So negative 9x and negative 5x is negative 14x. And then notice I can reduce, right? So I can reduce those. So the factor is 3x minus 5. And so therefore the answer is 2 times 1 is 2. Divided by 1 times x minus 3 is x minus 3. So there's the answer. So now part D did not have any choices. So you would have had to say that the answer is 2 divided by x minus 3. Okay? All right, 14. So let's get 14. 14, again, it did say no work necessary, but we all know we have to do some work there. So you have 3k minus 2 divided by 3k squared minus 19k plus 6 plus 1 divided by 3k squared minus 19k plus 6. All right, so again, notice I'm adding two rational expressions whose denominators are the same. And so therefore I can write this as one rational expression with that denominator. So my denominator is 3k squared minus 19k plus 6. Now this is, you're adding, so that's the easy kind. So this becomes 3k minus 2 plus 1. Now going ahead and combine like terms in the numerator, I get 3k, a negative 2 plus 1 is a negative 1. And the denominator, I get 3k squared minus 19k plus 6. Now, don't leave the answer like this. You got to see if you can factor and then see if you can reduce. Because if you can, you have to do that. So let's the numerator, the GCF is 1, so that stays 3k minus 1. The denominator, let's see what we get. Let's see, 3k, k, for positive 6, and we need this middle sign to be negative. So these are both negative here. For positive 6, let's go ahead and use 6 and 1. 6 and 1 is going to work, not 3 and 2. So let's put the 6 here, the 1 there. And then check. 3k times a negative 6 is a negative 18k. And a negative 1k gives me negative 19k. And then notice the 3k minus 1s divide out. And so I get 1 divided by 1 times k minus 6 is k minus 6. So there's the answer. Now, here's what I want to remind you of. See, I told you in our lessons to make sure that you show me how you reduce, right? So what happens is this. If you don't reduce, in your mind, you know that these divide out. And what some students do is they say the answer is k minus 6, but it's not k minus 6 because k minus 6 and 1 divided by k minus 6 is not the same thing. So don't say the answer, I'm going to say this, the answer is not k minus 6. Okay, it's 1 divided by k minus 6. That's why it's important to show those factors being reduced and ones in their places and in their opposites. One's a positive one, one's a negative one. All right, so make sure you understand that this and this are not the same thing. I mean, if you think about 1/5, you know that 1/5 is not the same thing as 5. Those are um, two different numbers, right? Okay. So the answer is 1 divided by k minus 6. So that's the answer for 14. 1 divided by k minus 6. And that is the key to this worksheet.